Today we're going to talk about exponential growth and decay. Exponential growth is when our quantity is going to increase by the same rate, which is r, each unit of time, which is t. So exponential growth formula is right here, and you need to write this down. Y equals a times the quantity of 1 plus r to the t power, and a has to be greater than 0. Y is our final amount. A is the original amount, so the starting amount. R is the rate of growth as a decimal. And then T is our time in normally years, but depending on the problem and what we're talking about, that could change. So, for example, 1, a painting is bought for $1,400 and its value then increases by 9% each year. Write an exponential growth function to model this situation. Then find the value of the painting in 25 years. Graph this function. State the domain and range of the function and what does the y-intercept represent in this context. So lots of questions here to answer. So the first one, it says write an exponential growth function. So we are going to fill in what we know in this formula. So y is going to be our answer, so we're going to keep that y. A is the starting amount, which it was bought for $1,400. And r is the rate of growth, and it's growing by 9%, so we're going to add 0.09, because that's 9% as a decimal. And then t is our time, how many years we have this painting for. And at this point in this question, it says write an exponential growth to model this situation. We don't know anything about those 25 years. So this is our equation, and then we can put in however many years we want to. It says then find the value of the painting in 25 years. So now we're going to plug in the 25 for t there. So we're going to have 1,400. 1 plus 0.09 is going to be 1.09. And the reason for that 1 is that its starting amount is the 100%. So all of it is 100%, and then we're adding 9% to it each year. So that's where the 0.09 comes in. So 109%, it's growing. And then the t is 25. So we're going to use our calculator for this. On my answer to the nearest cent, so it's about $12,072.31 that this painting will be worth after 25 years. Then they're asking us to graph this function. So I'm going to have to make a t-table here. Our y is our answer. X is really t, the number of years we're plugging in. So if I start at 0 years, it's going to be worth the $1,400 that I bought it for. Then after having it for 1 year, it's going to be worth $1,526. Then 2 years is $1,663.34. And 3 years is $18.13.04. And 4 years is $19.76.21. So now we're going to have to plot this. And I'm going to make a little jag here that says we are skipping up to this 1,400. And I'm just going to go by 100s here. All right, so 0, we're starting at 1,400. Then it's going to be just over 1,500 the first year. And then a bit over halfway, a little more than 1,650 the second year. 1813, so just a little over 18. And then 1976 is almost to 2000 here. So again, this is hand drawn, but you can see that it's starting to grow quicker at the beginning. And if we graphed this on the graphing calculator, we would be able to see the entire exponential form there of this graph. Next, we have to state the domain and range. Domain values are our x values, in this case t, and t is standing for time. So we cannot have any negative numbers for that. So t is going to have to be greater than 0 in this case, or equal to, because we could, as we just bought it, that's 0. And then range is our y values. And if you look at the graph, the smallest y value is 1400. It doesn't go below 1400 because, I mean, the graph would on your graphing calculator, but it isn't, we're not going to have negative years, so that doesn't make sense in our problem. So our y value has to be greater than or equal to 1,400. And then what does the y-intercept represent in this context? The y-intercept is 1400, and that is our starting value of the painting. Moving on, we have exponential decay. And the formula for that is similar. The only difference is that we're going to subtract inside the parentheses instead of add, because decaying means that our quantity is decreasing by the same rate each unit of time. So for example 2, the fish population on a local stream is decreasing at a rate of 3% per year. The original population was 48,000. Write an exponential decay function to model this situation and then find the population after 7 years and graph our function. So we have y equals a times 1 minus r to the t power. A is 48,000. That's what they started with. Our rate is 3%, so we're losing 3%. Remember, I have to write it as a decimal. And just writing the equation, we're going to leave t in there. So that is our answer to our first question there. Then find the population after 7 years. So we're going to plug 7 in for t. Type that in our calculator. And we are going to get 38,783.18. So about, since we can't have 0.18 of a fish, about 38,783 fish after 7 years. Now we're going to have to graph this. We're going to need a t-table. Remember, our x is really t here. And at 0, we have 48,000, so that's our starting value. And after 1 year, we're going to be down to 46,560. After 2 years, we're going to be at 45,163.2. 3 years would be 43,808.3. And 4 years is 42494.05. So now we are going to make that squiggly again. And this time 48,000 is going to have to be our highest value up there. I went down by 2,000s here just to try to fit everything on. So our starting value was 48,000. And then our first year we were down to 46,500, so just a little bit above there. After 2 years was 45,000. After 3 is 43,800. And 4 years is 42,400. So you can see it's starting to slow there. This is a decay, so it's going down. We're decreasing as time goes on. All right, and then our last question says the graph shows the value of 2 different shares of stock over the period of 4 years since they were purchased. The values have been changing exponentially. For each stock, write an equation of the function that represents the value of the stock, and then describe and compare the behaviors of the 2 stocks. Stock A, its value at 0 years is 16, and after 1 year, it looks like it's at 12. So to find what it's changing by, we're going to take the second one and divide it by the first one. So 12 divided by 16 is going to be 3/4, which is 0.75. So that tells us it's going down because that's less than 100%. And you can see that from the graph just looking at the picture as well. But that's just clarifying that we do have our right answer because it is decreasing here. So our initial value is 16. It's changing. It's going down because it's less than 100, so it's going down by 25%. And then T would be our time there. And then for stock B, we're starting 0 looks like it's starting at 5. And 1 would be at 6. So take the second one and divide it by the first one. And 6 over 5 would be 1 1/5, which is the same thing as 1.2. So that's over 100%. 1.2 would be 120%. So this means this one's increasing by 20%. So our equation, our starting value was 5. We're increasing, so 1.2. And then T is the number of years if you want to see what it's going to be at in 10 years or 20 years or whatever you want to plug in there. And then it says describe and compare the behaviors of the 2 stocks. So A is definitely a decay. B is a growth. And stock A starts higher, but after it looks like 2.5 years, they meet, they're equal after 2.5 years, and then stock A is no longer the higher stock. Stock B then becomes worth more. So higher initial value. This one has a lower initial value. And after 2.5 years, it's worth less, so it's lower in value. And this one, after 2.5 years, it's higher value.